Good afternoon, everyone, and welcome to our webinar on core engineering concepts. My name is Syed Hamad Gilani, and I will be your host for today's session. In this webinar, we will explore the fundamentals of core engineering concepts and their practical applications. Core engineering concepts form the foundation of various engineering disciplines, including mechanical, electrical, civil, and aerospace engineering. These concepts are crucial for designing, developing, and optimizing engineering systems. Today, we will delve into the key aspects of core engineering concepts and discuss their significance in real world applications. Now, let's meet our expert speaker for today's session. We have engineering Zeeshan Ahmad, who holds a BSc in civil engineering from NUST and an MSc and PhD from UET Peshawar. Currently, he is serving as a superintending engineering in the C&W department KPK. With his vast experience and expertise, engineering Zishan Ahmed will share valuable insights on core engineering concepts. Now, engineering Zishan Sahab, you may lead now.
Assalamu alaikum everyone. Thank you for inviting, and I hope my voice is clear and visible, audible to all. Okay, so let's start. Today's webinar is on the fundamentals of the structural analysis and design, and it's been organized through the BIM PSCC Pakistan. Let's have a brief introduction of myself. As explained by Saru, that I have been in the field of civil engineering for over 15 years, and I have been involved in some designs also, and familiar with different softwares. Is the ETABS SAFE or SAP 2000, and along with that, the Strat Pro. Some are CDC projects also, and also familiar with the BIM modeling. And in my research, I have done work on Diana FEA, similar to the Abacus, and also Seismostruct and AutoCAD. I will, in the end of my presentation, give a brief overview of these different softwares. And along with that, I've been involved in the research writing and publishing, and also expert opinion related to the execution of the civil engineering works. And also being part of my organization, I've been involved in the procurement. So for that, I can also assist and guidance. And currently, I've been involved in learning and working on the generative AI. So I will recommend every one of you to have familiarity with this, the trending technology, and make full of use of that. And in the end of that, the course learning platforms will also be shared. And if you want to find me, you can find me on the LinkedIn by the link that I have provided. So coming to the next slide. This is the sequence of presentation. I will start with the load paths and the buildings and their method of designs and the type of structural system that is in use and the different problems and their effects on the structures. Further, the foundation design and their modeling techniques, and followed by that, the code provisions, the dynamic actions on the buildings, and the different softwares overview. And at the end, of opportunities for learning. If you want to enhance your learning abilities, you can do that. So coming to the next slide, let me remove these lines. Okay. So during the earthquake shaking, the inertial forces are transferred to the buildings and they travel along the different load paths. These are called the load paths. And through different structural elements, they are finally transferred to the foundation. The building geometry is very important. If you have a simple and symmetrical building, then the load paths are very easy. But when you have a complex building, you might have different sort of load paths. So in your field, it is not necessary that you get an ideal type of arrangement based on the site requirements, and as per the client requirements, you can get any type of shape. And with the advancement in the field of the civil and structural engineering, any type of building is now possible, and you can go for any unsymmetrical shape, which I will explain in the coming proceeding slides. So moving to the next slide, the major structural elements in a building are the frame members, that is the beam, column, and the slab, and finally the footing. And the non-load bearing can be the cladding walls, the partition walls, the glass facade, or any architectural finishes that is used in any type of a building. The loads in the building, they may be dead loads, live loads, the hydrostatic and the soil loads, and the snow loads. These are classified as the static load. And in the dynamic, the major are the wind loads and the seismic loads, which are generated by the earthquake actions. Next slide. As you can see the building, if you can analyze its behavior, so it is dependent on the type of loading. One is the gravity load and the other is the lateral load. In the gravity load, the loads are the self load of the building, the different furnitures or different occupancy that is there, the finishes, so that are classified as a dead load, which remains static throughout its life. And the other is the lateral load, which is the wind or the earthquake action, and they also are transmitted to the building. So if you do not consider the lateral load effect, the building will be in the shape of resisting only the gravity load, but not the lateral load. So both of them is important. And if you can see in the picture there, I will turn now the pointer. So you can see that this is the elastic curve for the gravity load, and this is for the lateral load. So moving to the next slide. Okay. The various methods of structural design, one is the classical one, which is the working stress method, and it is based on the allowable material strength, and they are controlled by the deformation limits. It is very obsolete and not used nowadays. The latest was the ultimate strength design, where you factored your loads, and based on the factor loads, you then design the building. But the latest trend is the performance-based design, which considers the ductility, the deformation capability, and the load capacity at large deformation. In simple meaning, in performance, it is the based on your desired output. On that base, you design your building. So it can be any shape, any level, and any type of material used. So the limits are not have any, it does not have any limits, and you can go for any type of construction as per your requirement. The structural systems, they can be the gravity load resisting systems or the lateral load resisting systems, and they are maybe the slab supported on load bearing walls, on column beams. And if you have a combination of beams, then one is a primary beam, the other is a secondary beam, and the beam can be also supported on walls or columns. And in the lateral system, it can be single system, the moment resisting frame, the brace frame, shear walls, tubular system, and the dual system, which I will explain in the preceding slides. So you can see different images of the building. These are the latest construction techniques used, and you can see that any type of geometry is possible with the advancement in the performance-based earthquake engineering. Now, what is the wall bearing system? They are the classical residential houses that we see, and in which the masonry walls, they provide support for all types of loads. And it is mainly used for residential purpose, where we have light loads and in low seismic zones. And their capacity is maximum 2 or 3 stories. So they don't have much lateral load resistance systems, and they are just for light loads only. Now, there is moment resisting frames, which have assembly of the beams and columns, and in which they are rigidly connected to the one another, and they provide the lateral resistance by the rigid frame action, and they provide a great deal of flexibility in planning, that is, no braces are required, and its performance is very sensitive to the detailing and the workmanship at connections. And the bad aspect being that they are expensive and a lot of materials plus labor intensive work is used. And large deflections can lead to high non-structural damage in earthquakes. For example, the 1994 Northridge earthquake. What is happening is that the code has the different performance level, the immediate occupancy, life safety, and the collapse prevention. Collapse prevention does not mean that the building will collapse, but it is on the verge of collapse, and you have ample time to get out of the building. But what happens is that the non-structural elements, for example, the architectural finishes or the furnitures or the walls, they collapse, and they can cause two types of problems. Either they block your passage of escape from the building, and secondly, due to the falling of these, they are a source of a hazard for the public inside the building. So either the safety of the building is important, but also the safety of the public is also very important. The other is the shear walls, which have the vertical members, and they are capable of resisting the horizontal forces through the capacity, and it provides the stiffness. If you have the stiffness irregularity, it eats through your stiffness, and you can get better results. So this is an option when you have limitation in the size of the beams and columns, and you have no other option. And along with that, if the client also has the provision, you can then go with the shear wall, which enhances the stiffness and the performance of the building in case of strong earthquakes. And with that, you can also go for high-rise buildings also. The other is the brace frame. It is the arrangement of different braces. You can have the diagonal framing, the X bracing, the V bracing, and a combination of that as shown in the picture. And they help in reducing the overall lateral displacement of the building and reducing the bending moments and the shear force demands on the beams and columns in the building. So they act as a reinforcement in terms of reinforcing your members and reducing the demands on the different beams and columns. Now, based on the stories, you can have mid-rise buildings when you have G plus 10 story buildings, and tall buildings when the floors are more than
Sir,
20.
continue रखिए, आप
And
continue
if you have more, जी आवाज नहीं आ रही मेरी? Hello, kindly confirm. Is there any issue with the voice?
No, sir.
No, Dr. Zeeshan, your voice is clear. Please continue.
Okay. In the high-rise buildings, when you have more than 100 stories, then they can be called as high-rise buildings, also termed as skyscrapers. Now, what is the tube system? The tube is the name given to the systems where it is constructed in order to resist the lateral loads. You have a central arrangement. This is the same as the shear walls, but in a symmetrical way so that it gives a good stability. And it was when invented, it was used first in the 1963 USA. And they are heavily reinforced structural walls, and they are constructed in a shape which is also called shaft and core, and they gives a very good sort of arrangement in terms of the number of floors can be increased. And it has a central perimeter tube, which is also central core, and their interconnection is important between the perimeter tube and the central core. Now, the frame type tube system, one is the bundle tube system and the other is the brace tube system. The frame tube system, the most common being the old damaged or the destroyed building of the World Trade Center that was in 2001, which was at that time the tallest building in the world. It was based on this frame tube system. And based on the number of stories, you can either have a rigid frame, the frame shear truss, the belt truss, and you can go on with any type of arrangement. So this was at that time the most common practice, and the tallest building was constructed using this analogy. Now coming to the bundle tube, if you have visited or seen the Burj Khalifa building in Dubai, it is currently the tallest building in the world. It is spanning about 828-meter height. So it is a combination of this bundle tube. So with the advancement in the structural engineering, you can see that the cores are now in the not in necessarily in the central, but also scattered along the different parameters. So it makes it possible, and all this is based on the performance-based earthquake engineering. And another important thing to highlight is that this building was constructed or designed using the ETAP software. So it is a very powerful software. And to further advance in this field, currently Saudi Arabia is constructing a building which is more than this building height, and it is about 1 kilometer, 1,000 meters. So any sort of invention can be possible in the field of structural engineering. Now the brace tube system, it has different braces, and they just like the truss arrangement, it gives stability to the building, and they are also used for high-rise buildings. Now the outrigger truss system, when you have unsymmetrical type of a shape, like as seen in the building, you can go for this outrigger truss system. It is a simple truss spanning over the full height of that story and across the full width of the building. And its role is to make the columns act together in resisting the overturning moments acting on the building, majorly the lateral loads. And the pairs of the columns, they generate couples of axial tension and compression to counteract the overturning moments, and this reduces the overall bending effects in the column. Now, another is the die-grid system. You might have seen this sort of pictures on the internet. It is also a diagonal grid, and it is a framework of diagonally intersecting metal, concrete, or wooden beams that is used in the construction of building and roof. It requires less structural steel than a conventional steel frame, and it is modeled as a beam and subdivided longitudinally in different modules. And this is an experienced structural system in which all the perimeter columns are eliminated and consists of only inclined columns on the facade of the building. So these are all the inventions in the structural engineering using the performance-based earthquake engineering technique. Now coming to the slabs, you might have seen this waffle slabs. This is commonly used in places when you need to skip the interior columns, and they are basically two-way slabs. And for longer span, they are used. Commercial halls, they have this sort of arrangement. The other is the flat slab, in which you also don't have the interior. The main advantage of flat slab is that you can construct any wall if you have a room size of any dimension and you want to change it. So by using the flat slab, you can then discard that wall and later on place it again. So the important aspect is the punching shear that must be calculated, and it should not or exceed the design limits. Otherwise, the punching failure is there. It may have the drop panel or without drop panel, and if you don't have the drop panel, it is called a flat plate. Now, the different torsion irregularities. One is the when your center of mass does not coincide with the center of rigidity. Center of rigidity is the summation of all the lateral forces and their centroid. This is the center of rigidity, and when they don't coincide, then you have the twisting or the torsion effect. Torsion induces the shear forces, and along with the shear force, this additional torsion needs to be catered for in the lateral forces, and then if you are designing the ties, you need to check for torsion also. And as shown in the previous slides, the inclusion of the shear wall, it helps in moving the or reducing the gap between these 2 points, and you are able to increase the stability and make it less torsion resistant. For that, the codes have the provisions that if the ratio between the Dmax, that is the maximum displacement to the average, is greater than 1.2, then torsion irregularity exists. And if it is greater than 1.4, then extreme torsion irregularity exists. So, and when it is less than 1.2, then it means there is no torsion irregularity. It depends on the geometry mainly, and also on the forces that is acting on that. Now, if you have a properly designed building, but you have less stiffness in the bottom floors, particularly in the commercial buildings when we have open spaces so that people can come in and out, and also the car parking, you have non-provision of walls, so that causes the soft story effect. And in the preceding slides, I will show the images when buildings are properly designed, and even low floors, 2 floors or 3 floors. But due to this effect, the plastic hinges, they are prominent in the base floor. So they causes the yielding or tilting of the column, and resultingly, your building, they collapses. The other is the deformation capability. If you increases the floors, then you have the second order, that is the P-delta effects, which is the geometric irregularity. And this needs to be also catered in your design. Now, what is the weak story effects? Weak story, as per the ECI code, it has the structure has a weak story if the shear strength of the story is less than the 80% of the shear strength of the story above. And extreme weak story is there if the shear strength of story is less than 65% of shear strength of story above. Now, coming to the damages, one is the earthquake of Turkey 2003. Kindly mute kar this sabko. How I don't know how to mute. Dr. Vikas, kindly guide how can I mute the people? Okay. Just muted now. Sorry. The earthquake earthquake of 2003 earthquake, although the building was properly designed, but what happened is that due to the short column effect, the failure occurred. So the out of plane infill failure was there, the soft effect was there, and the short column effect was there. Similarly, the 2015 earthquake in Nepal, it is only G plus 2 building, but you can see that the in-plane infill wall failure, they caused the short column effect, and you can also see that the presence of large openings and some portion restrained and other unrestrained, they cause this effect. Now, similarly, the Peru earthquake of 2001, it caused the in-plane wall failure, and along with them, the short column effect. It is only G plus 1 building. So it doesn't mean that you design the building and it cannot fail in earthquakes. All these effects, as I showed, they must be catered so that their effects are reduced. Now the foundation, it is very important, and it is the means by which the loads are transferred to the ground. So you might have a shallow foundation or a deep foundation. When the width of your foundation is greater than the depth of the foundation, then it is called a shallow foundation. And on the other hand, when it is less than the depth, it is called deep foundation. So the deep foundation may be the piles that we use, the piles mostly in the bridges or the buildings where the bearing capacity is very low. And for the shallow, might have the pad foundation, the strip footing, the rough footing, or if when you have a differential heights along the structure, then you can go for foundation. Selection of foundations, you can either have the soil close to the surface, capable of supporting the large loads. When you have capacity, then go for the shallow foundation. And when there is a low bearing capacity and deep under the ground, you have the strong strata available, and you can go for the deep foundation. So the shallow can be either rough footing or a step footing, as shown in the previous slides. If you are modeling using the finite element method and software, then you can either model the soil as point spring, line spring, or area spring. Point spring is when you design for the pile foundation, and area spring, it should be modeled for the raft or the isolating footing. And line spring, it is used for the beam or the step beams. Now coming to the ACI code, the you might have seen this in your engineering curriculums, but just to have a quick refresher, when you are using the lightweight concrete, you can go for this formula, and you are using for the normal concrete. Then similarly, for the rebars, you can use the different formulas as per the ACI code. And if you have don't have any idea about the dimensions, you can start with the trial dimension of using the column size as h by 10, and based on that, you can then approximate your sizes and check your analysis. One thing to note from the practical point of view is that the column dimension should always be in the multiple of 3, so that it is easy for the fabricator to fabricate the formwork. And if you have a rectangular building, the larger face should lie in the larger dimension. And as per the current ACI code, the minimum column dimension, if you are designing a structural column, it should be not less than 12 inch. And the columns should be stronger, and the beaks should not be stiffer than the columns, so that if the columns capable of bearing that capacity, and if the columns are weak, then they will fail. Ultimately, the building will fail. So based on the ACI code, different moment of inertia, they have their modifiers used as per the crack section analysis concept, and you can use them for your analysis and designing the softwares. Other thing is the detailing of the column. If you are using the ordinary moment resisting frames, then the detailing should lie at the junction of the beam and the column. And if you are using the special moment resisting frame, then the overlap should lie at the mid height of the column. Now for the beams, similar to the columns, the sizes should be in the multiple of 3 inch. And if you don't have any design requirements for the strength of material, so you can assume it to be more than that of the slab. Typically you use 4000 psi and grade 60 use, and the modifiers used are 0.35, and the table 9.3.1.1 gives you the depth of the beam for using your analysis. Similarly, for the slabs, the trial size you can select for any building. If you don't have any size available, start with 6-inch and do your analysis. And then based on the requirements, you can then modify your thickness of the slabs. And for the footing, if you don't have any idea about the number of the thickness of the footing, then the thumb rule is that you can approximate using the 3 to 4-inch multiple. For example, if you have 3 floor available, so you can use the 4 multiplied by 3, that means 12-inch, and approximate your size with that. And based on your analysis, you can then modify. And their modifiers are also shown, and their crack moments are also given as per the ACI code. For walls, the thicknesses generally vary between the 6-inch and the 12-inch, and the trial sizes vary between the 12-inch, 15-inch, or 18-inch. And if you are using a lift, the modifiers are also given, and for the wall tank, they are also given. And if the thickness of the wall is greater than 18-inch, then you can model them as shell thick. Based on the different load occupancies as per this is from the design of concrete structures by the Nielsen, and also in the Building Code of Pakistan 2005 version. These are the different flow loads that you can assume in your design. And if you have the, for example, the school building, the load will be for 40 pounds per square foot. And if you have a hospital, it will be different. And similarly for the bridges and other type of offices, they have different type of loads, so that you will use in your design. Similarly, this is also for the different types of loads in terms of the concentrated, in terms of the pounds also. The soil profile types, they are different type of soils. When you have either hard rock, you can use SA, medium rock, SB, and carry on. As you increase the number, the soil type strength reduces, and you get to a very weak soil. So these are all based on that criteria used by the UBC 97 and also by the Building Code of Pakistan 2005 version. In the latest Building Code of Pakistan, they have used the regulations of the International Building Code, which is based on the spectral acceleration. So these are also used, but the latest you can go study from the Building Code of Pakistan 2021 booklet that is available online, and you can find it is based on the spectral acceleration. Spectral acceleration is basically the response acceleration when you have the time period known and it has some sort of damping. It is typically assumed as 5% damping in the building. And the conventional formula for calculating the time period is this is the formula used, or you can multiply the number of floors by 0.1, you can get the time period of the building. Now, these are the different seismic zones as per the UBC 97 or the 2005 Building Code of Pakistan, and they have different zones. It starts from the 2A, 2B, and goes up to 4. The 4th zone means the higher risky zones, and as you move from the bottom, you can get the low seismic zone. The table and the charts are available in the building code. You can easily see in them. But in the latest code, they have updated and they have used different spectral accelerations, and you can also see that. So these are different, and as per the ACI code, they have different load combinations, and you can use them using the earthquake factors also. For example, if you have the seismic provision there in your design combination, then you need to multiply all the factors by the 1.1 multiple to fulfill the requirements of UBC 97. And after analysis, you can perform different checks. For example, the deflection under the live load. This is from the ACI code, the drift requirements, and the torsional irregularity. Similarly, the drift, what is the drift? It is the difference between the lateral displacement of one float relative to the other or below. And if you divide this by the story height, you get the story drift ratio. And the drift requirements, if you have time period less than 0.7 second, then use the this formula, and if you have time period greater than 0.7, then use the other formula. Okay. Now, design of columns as per the ACI code. This is the different formulas used. The longitudinal reinforcement, it should be between 1 to 8%. And the ties requirements are also shown, and their different sizes have different limitations. And you can also use the formulas for checking the maximum spacing of shear reinforcement. Similarly, for the design of the beams, there are different formulas given, and minimum reinforcement should be more than this formula values. Otherwise, use the formulas values. And the main bending moment that we use in the design is the M3, which is about the 1, 2, that is the 3 axis, and the shear force is uses the V2. So when you if you are using the ETAP software, you have the M3, which will be the bending moment, principal bending moment that will be using for calculating the area of steel, and similarly the principal shear force will be the V2 force. Okay. So the shear force requirements for the beams, as per the tables shown, you can use them for your analysis. Now coming to the foundations, you have shallow foundation. This is the allowable bearing capacity formula. It is the ratio of the ultimate capacity over the factor that we are using. And when the FPS system we are using, the limit is that it should be deflection should not be more than 1 inch. So for that you can use this formula. And the minimum reinforcement, you can use these formulas as per the table given. And for the two-way footing, you can study these provisions as per the code. Now coming to the mode analysis. What is mode analysis? It is the vibration or the oscillation of the building under different modes. What is the mode? It is the shaking of the building under the different time interval as the lateral load acts on the building. So it is the modal analysis uses the overall mass and stiffness of the building to find the various periods at which it will naturally resonate. When you resonance is when the time period matches with the fundamental time period, then you have the resonance, and at resonant point you get the maximum damages. So for that we perform the modal analysis for critical buildings. And the gravity and the lateral loads, the dynamic forces, they causes the base acceleration, and the base acceleration they generate the shear forces, and they are then transferred to the building, and you get the different floor accelerations, and from that floor acceleration your demand in the building can be determined whether the one floor has lesser demand or the other floor has higher demand. Similarly, for dynamic action of the wind, you get different forces and they are applied to the building. And from these forces, you get the performance of the members. And these factors should be considered so that under the wind force or the earthquake force, the drift are within the allowable range, and so that you don't get excessive drifts causing the sway of the building and causing the failure of the building. Now, diaphragm is very commonly used. These are the mathematical operators which transfers the lateral force to the vertical members. And it is a way of transferring the lateral forces to the vertical members like the beams, columns, and shear walls. And the most common lateral loads on these are the from the wind or the earthquake actions. The diaphragms can be rigid, semi-rigid, or flexible. The softwares do have these provisions in the dialog box, and they ask you which type of diaphragm you are using. And the seismic analysis method, they can be static analysis or the dynamic analysis. The static analysis is the linear static analysis or the non-linear static analysis. And the dynamic analysis can be linear dynamic analysis and the non-linear dynamic analysis. The linear static analysis, it is the equivalent static method. The design-based shear is calculated for the entire building, and they are distributed along the height of the building. It saves time, but it is assuming only the elastic nature of the building. And the linear dynamic analysis, different mode method, there are responses in which the building vibrates. Each pattern has its own frequency, time periods, and how much mass participation is it involved in its mode. The first mode is considered as the primary mode, and is when you have a number of floors more than one, then you have to calculate the participating factor for each mode, and then you have different parameters as per the modal analysis technique used. Time history. In time history, we use the actual earthquake ground motion, and we apply it in our building. For example, if you have the different earthquake, for example, the Kobe earthquake or the Northridge earthquake or the Loma Prieta earthquake or any historical earthquake, you can then be able to judge the building performance under real earthquake data. So time history analysis is very much recommended, but the problem is it is too time taking, and it involves very high computational effort. But to get a realistic data, you need to have the time history analysis. The other is the pushover analysis. It is mostly used in the research, and it uses a different performance level as per the code. For example, the FEMA 356 or the Eurocode or the any other NEHRP or the HASIS, they have different performance levels. And in that, we either use the force control method or the displacement control method. And if you are using any one of them, you sequentially apply it, increasing the displacement or the forces on the building, and you reach to a point where you get the failure of the building, and from that you then determine the elastic range, the yield point of the building, and then you calculate the base shear and the ultimate displacement. From that you can get the response modification factor, displacement activity, the effective stiffness, and other sorts of parameters. So a very useful data can be then used. And if you want to replicate the pushover data to like time history analysis using the spectral acceleration, you can use either the FEMA P58, that is the PAC document, or the N2 method. It can then replicate your the non-linear static to a non-linear dynamic data, and you can then calculate the engineering demand parameter. It can be story drift or the stiffness or any sort of behavior that you are intended to achieve. Now, I told you about the short column effect, but the slender column is also not acceptable. So you have to have a balanced arrangement. If anyone asks you a question that either short column effect is acceptable, you can say no. So the slender column is also not recommended. So the buckling analysis needs to be performed so that the member do not buckle under the torsional effect or the flexure effect or a combination of the flexure or a torsional effect. Now dampers, what are dampers? Dampers, just like shock absorber in a car, if you are driving on a road and you came across any potholes in the road, you get some sort of vibration. Due to the presence of the shock absorber, the shock is not transferred to you and you don't feel uncomfortable. You only feel slight shaking. So the dampers are the similar types of arrangement. And what is damper is it absorbs the energy, and it causes the reduction in the oscillation of the building. So they are also used conventionally in the high-rise buildings so that they can absorb the vibrations and make the building more stable and reduce the demand on the building. Now, different softwares overview. Some in places STAT Pro is used. The difference between the STAT Pro and CSI software, for example, ETAPS, SAFE or SAF, they are used. That in STAT Pro, you have to enter the calculate yourself, but the CSI software, they automatically calculates the self weight, so you do not need to enter the self weight. And along with that, if you are comparing different software, for example, SAP 2000, it is mainly used for any type of structure. It can be a building or a bridge or a water tank. But the ETAPS, it is primarily used for buildings, and it is a very easy, having very easy interface compared to others, and even the SAP 2000. Nowadays, the CSI company has split it SAP with CSI Bridge. You can use it specifically for bridges, but SAP 2000 has the ability to use design any sort of design analyze any sort of infrastructure. And in the previous versions, for example, in 2016 version of ETAPS, they have built-in CSI detailer. So you can also detail your design. But nowadays they have used the other software, that is the CSI detailer. And you can then export the data to a CSI detailer. And from that, you can then detail your drawings, etc. Tekla and Rivet are used for building, BIM information modeling. Rivet, it has a very vast type of modules, and robot structure analysis you can use in combination with Revit. But the Revit data is not limited to robot, although robot is the same as the Revit, but you can transfer your data to ETABS or SAFE also, so you can then design it there. Stat Foundation Advanced, it is by the Stat Pro company, but you can use it for the design of foundation from the data using the ETAB. So they are all interchangeable and not limited to any specific. Midas has also the same. It is also used across different countries like the Philippines or Thailand, and they are also having very advanced features. So Tekla is also BIM software, and you can use it for the steel detailing. It is best recommended for steel detailing for design of connections. SAFE, it is mainly used for the design of the slabs, the footings or the walls. You can analyze your building in ETABS or SAFE, and then you can transfer it to export it to SAFE for designing there. RCDC, it is also very good software from your design analysis in the ETABS or SAFE. You can then export your data to this software, and it will design your slabs and also detail it for you. You can have an additional option of detailing using this RCDC. Although I skipped one logo that is of the Seismostruck, it is very beautiful software also. You can use it for research purpose and also for different sort of designing. So the concept is the same. You can use software, but you must have the basic knowledge and the formulas that I mentioned. You must be able to check your analysis based on that. You cannot 100% rely on software. Software is the based on your input. Whatever details you give, it will give it output. But you need to check your input also and compare it with the code provisions, whether it is within the allowable limit or not. So 100% using the software is also not recommended, and the use of the conventional manual method is also not recommended. You can use a combination of both so that your time is saved and you can get good output in a short span of time. Now, some BIM. In BIM, you can use different in the conventional system. We used to have the manual drawing, drafting techniques. Then, with the advent of AutoCAD, it was possible to use the computer-aided design method for drawing sheets and drawing the plans. But the Revit, it has advanced it, and you can actually visually see the 3D of the building. You can have different clash detections. You can carry out the energy analysis. You can check for sustainability. You can do the facility management, and you can also use for the safety and also for the estimation. So it is a very powerful software, and it has eased the work and also give you more practical and realistic view of your model, which is not yet constructed. In the end, I will share some programs that is offered by the BMP CC Pakistan. We have these sort of courses available, and based on the requirement of the students, any sort of course can be arranged, and you can find us on the YouTube, the LinkedIn, Facebook, or the WhatsApp, and you can take advantage of this mainly online platform, and at your own convenience, you can improve your skills and be able to compete in the market. So with that, I end my presentation. Thank you all for listening. And if you have any questions, I have be happy to answer.
Assalamu alaikum, sir. Am I audible?
Yes, I can hear you.
Yes, sir. Thank you for such a good presentation. My question is that I have heard from my seniors that they prohibit pursuing career in structural engineering in Pakistan because the market has very few projects and opportunities are very less. Can you please guide in this regard?
Kindly introduce yourself. You are an undergraduate student or a master student?
No, I haven't done a master's yet. I am an undergraduate of Military College of Engineering, Misalpur.
Okay, okay. This statement is not correct. You know, if you have heard about freelancing, freelancing has advanced your boundaries. It is not dependent on your specific region. What we, unfortunately, what we follow is that we only think in within our boundaries. We do not think out of the box. Nowadays, even e-commerce, must have heard. You are sitting at your home and you are doing business online across the globe. So with freelancing, there are many remote jobs and people are earning good salaries from that. You can find it on the LinkedIn, on the freelancer website, the Upwork, the Fiverr. So the main thing is that once you are skilled, you will compete easily in the market, whether you are any of any regions. Dr. Waqas is present here. I learned a lot of structural engineering things from across outside Pakistan. So it's not dependent on your current world. The internet, it has made our life so easy that we can go for any region and look for opportunities.
Right, sir. Thank you so much.
Yes, and the other question? You can ask in Urdu if you are not comfortable with English.
Assalamu alaikum, sir.
Wa alaikum salam.
Sir, currently I am a student of the final year civil engineering department.
Okay.
So, सर मेरा क्वेश्चन ये है कि बेसिकली स्टूडेंट्स इस चीज़ में उनको गाइड किया जाता है कि 6 से 7 सॉफ्टवेयर हैं डिज़ाइन के। तो सर ग्रेजुएशन के दौरान वो सारे सॉफ्टवेयर नहीं सीख सकते। तो सर इस तरह के कौन से सॉफ्टवेयर हैं जो आप रिकमेंड करेंगे कि ग्रेजुएशन के दौरान वो सॉफ्टवेयर सीख लें डिज़ाइन पीरियड के लिए जो उनको आगे जॉब में उनको हेल्पफुल हो?
अच्छा, आपके जो करिकुलम होता है ना, उसमें आपको बेसिक सिखाए जाते हैं, ठीक है? Whatever we learn in our engineering, these are all basics, ठीक है? बेसिक्स आपके स्ट्रांग होने चाहिए, ठीक है? आप बेसिक्स आपके स्ट्रांग होंगे तो आप किसी भी सॉफ्टवेयर पे वो इजीली हासिल कर सकते हैं। सॉफ्टवेयर जस्ट एक टूल है, ठीक है? कॉन्सेप्ट आपके पास है, सॉफ्टवेयर के पास नहीं। कॉन्सेप्ट के बेस पे आप सॉफ्टवेयर को कहेंगे कि मुझे ये चीज इस तरह करनी है, ठीक है? तो मेरी रिकमेंडेशन ये होगी कि आप पहले बेसिक सीखो। वंस यू आर मतलब आप कॉम्पिटेंट इनफ कि आप उसको इंडिविजुअली या फॉर एग्जांपल आपको इंजीनियरिंग में एक प्रॉब्लम कराया जाता है 2D फ्रेम का, ठीक है? तो उसकी बेस पे आप आफ्टर योर एग्जाम यू कैन देन गो फॉर अ बिल्डिंग डिजाइन यूजिंग मैनुअल अप्रोच। आप उसको पूरा हासिल कर ले, देन यू कैन गो फॉर एनी सॉफ्टवेयर। और जैसे मैंने बताया कि द वर्ल्ड टॉलेस्ट बिल्डिंग इट वाज कंस्ट्रक्टेड डिजाइन यूजिंग ई टैब्स। सो इट इज वेरी इजी। आपको इजीली विद इन 2-3 मंथ्स आप उसमें अच्छा खासा अबूर हासिल कर सकते हैं, लेकिन प्रोवाइडेड कि आपकी बेसिक स्ट्रॉन्ग हो, ठीक है? और इसी तरह अगर आप ब्रिजेस पे करते हैं तो सैप यूज कर सकते हैं, CSI ब्रिज आया हुआ है, ठीक है? अगर आपका बिल्डिंग इंफॉर्मेशन मॉडलिंग में आपको अबूर हासिल करना है तो आप रिविट सीखें, ठीक है? स्टील स्ट्रक्चर्स करनी है आपको बिम के थ्रू तो टेक्ला करें, ठीक है? मिडास में भी ब्रिजेस होते हैं, उसमें भी आप कर सकते हैं। तो सारा जो मेथोडोलॉजी है वो एक ही तरह की है, आपके कॉन्सेप्ट्स पे डिपेंड करता है। ये सारे टूल्स हैं और ऑल ऑफ देम आर रिकमेंडेड।
जी सर, मेरा एक क्वेश्चन है।
यस।
सर सॉफ्टवेयर की बात करें हम लोग, ऐसा होता है कि हम सॉफ्टवेयर तो सीख लेते हैं। सर हमें जब सेमेस्टर ब्रेक होता है बीच में तो हम उस टाइम पे सॉफ्टवेयर सीख लेते हैं, लेकिन वो कुछ टाइम के बाद वो वापस से भूलना स्टार्ट हो जाते हैं। तो क्या ये
देखिए
सबके
कोई
साथ
भी
ही ऐसा
चीज
होता है या सिर्फ कुछ
कोई भी
साथ
चीज
ऐसा होता है?
कोई भी चीज जब आप प्रैक्टिस नहीं करते ना तो देन यू स्टार्ट टू फॉरगेट इट, ठीक है? आपने देखे होंगे डॉक्टर्स जो होते हैं, ठीक है, इफ दे डोंट प्रैक्टिस उनसे सब कुछ भूल जाता है, ठीक है? इवन आवर इंजीनियर्स जो हमारे डिफरेंट जगहों पे काम करते हैं, व्हेन दे गो इन एडमिनिस्ट्रेशन, तो अब किसी जगह पे आपने CSS ऑफिसर देखा होगा, वो इंजीनियर कैडर को होगा, उसे अब इंजीनियरिंग का पूछे उसे भूला होगा क्योंकि वो प्रैक्टिस नहीं करते हैं। इसी तरह वकील होता है, जब वो प्रैक्टिस नहीं करते उनसे सब चीजें भूल जाती है। तो प्रैक्टिस इज मस्ट। और बेस्ट तरीका ये होता है कि जब आप कुछ पढ़ते हैं क्लासेस में, तो आप नोट्स लेते हैं, ठीक है? तो अपने टाइम को बचाने के लिए आप फॉर एग्जांपल एक वीडियो देख रहे हैं, तो फर्स्ट टाइम आपको 2 घंटे लगेंगे, नेक्स्ट टाइम आप देखेंगे आपको 1 घंटा लगेगा, उससे अगले नेक्स्ट टाइम आप देखेंगे आपको 15 मिनट में चीज़ समझ आ जाएगी, ठीक है? तो बेस्ट यही होता है कि आप अपने साथ नोट्स बना के रखा करें। जब आप नोट्स को दोबारा रिविज़िट करते हैं, तो आपका वो सारे मेमोरी जो होती है, वो रिफ्रेश हो जाती है। तो ये इट्स नेचुरल कि जब आप प्रैक्टिस नहीं करते, आप भूल जाते हैं चीज़ें। Yes. Any other question? जी, वालेकुम सलाम।
सर की क्लासेस कब से स्टार्ट होंगी होगा और वीक में कितने डेज करने होंगे सर?
क्लासेस से मुराद कौन सी क्लासेस?
सर ये जो हम इसको कोर्स करेंगे ना, ये स्ट्रक्चरल इंजीनियरिंग, ये इसका
क्लासेस का तो आप जो एडमिनिस्ट्रेटर्स हैं उनसे पूछ लें, वो आपको गाइड कर देंगे, ठीक है? जब प्रोग्राम में होगा तो आपको इंटीमेट कर दिया जाएगा। और जो मैंने आपको ये स्लाइड दिखाई है, ये वाली, इस पे भी आप राब्ता कर सकते हैं। व्हाट्सएप का भी ग्रुप है, उसमें भी आप ज्वाइन कर सकते हैं, उधर भी आप क्वेरी डाल सकते हैं, तो जो मॉडरेटर्स हैं वो आपको फिर इन्फॉर्मेशन बता देंगे। इसके अलावा आप ऑनलाइन प्लेटफॉर्म्स पे भी सीख सकते हैं। यूट्यूब पे हो गया, कोर्सेरा पे हो गया, यूडेमी पे हो गया, तो डिफरेंट प्लेटफॉर्म्स आर देयर।
थैंक
वेलकम जी।
अस्सलाम वालेकुम सर।
जी, वालेकुम सलाम।
एक्चुअली सर मैं बैकग्राउंड जो है मेरा वो मैकेनिकल इंजीनियरिंग का है, और मैं पिछले कोई 8 से 10 साल से इंडस्ट्री में सर्च कर रहा हूँ, और अभी भी मैं एज अ प्रोजेक्ट इंजीनियर वर्किंग कर रहा हूँ। हमारे पास सर स्टील स्ट्रक्चर्स के हवाले से बहुत वर्किंग होती है, कुछ प्लेटफॉर्म हैं, कुछ शेड्स हैं। तो सर इस हवाले से कौन सा सॉफ्टवेयर बेस्ट रहेगा स्टील
स्टील
स्ट्रक्चर
स्ट्रक्चर
डिजाइन के हवाले
स्टील स्ट्रक्चर्स के लिए
से? जी सर। जी सर, स्टील स्ट्रक्चर्स के लिए।
ये जो मैंने आपको सॉफ्टवेयर बताए हैं ना, ये वाले,
जी सर।
ठीक है? इसमें कोई लिमिटेशन नहीं है कि आप सिर्फ कंक्रीट के बिल्डिंग्स कर सकते हैं। आप
ठीक
इसमें कोई सा भी स्ट्रक्चर कर सकते हैं।
ठीक।
कंक्रीट, स्टील, ब्रिक, वुडन, एनी टाइप ऑफ स्ट्रक्चर यू कैन डू इट।
राइट सर।
ठीक है, थैंक यू जी। और किसी का कोई क्वेश्चन?
Assalamu alaikum.
वालेकुम सलाम।
Am I audible?
जी जी, आपकी आवाज आ रही है।
I have a question about first order and second. इसमें क्या? Sorry. मेरा क्वेश्चन है फर्स्ट ऑर्डर और सेकंड ऑर्डर पी डेल्टा एनालिसिस के वाले से, तो कौन सा कब इस्तेमाल करना चाहिए और क्या लिमिटेशन वगैरह है?
पी डेल्टा एक तो ज्योमेट्रिक इरेगुलरिटी है, ठीक है? सेकेंडली, जब आपकी हाइट बढ़ती है ना, फॉर एग्जांपल अगर आप इन इलास्टिक रेंज में एनालिसिस करते हैं, ठीक है, देन यू नीड टू कंसीडर द पी डेल्टा इफेक्ट, ठीक है? इलास्टिक रेंज में टिपिकली पी डेल्टा को हम नहीं कंसीडर करते हैं। और जब आपके पास कोई बहुत ज़्यादा अनसिमेट्री हो, तो फिर पी डेल्टा इफेक्ट आता है। पी डेल्टा क्या होता है? एक तो आपकी लेटरल लोड के अंदर प्राइमरी डिफ्लेक्शन होती है ना, ठीक है? तो उस प्राइमरी डिफ्लेक्शन की वजह से सेकेंडरी डिफ्लेक्शन भी होती है, जिसको हम अगर प्राइमरी को डेल्टा 1 कहें, तो सेकेंडरी को डेल्टा 2 कहेंगे, ठीक है? उस केस में हम फिर इसको यूज़ करते हैं। जी, एनी अदर क्वेश्चन?
जी जी, कैन यू हियर मी?
जी जी, आपकी आवाज़ आ रही है।
जी जी। तो सर आपसे एक काफ़ी बेसिक सा सवाल है कि मैं भी एक ना बीएससी का 5th सेमेस्टर का स्टूडेंट हूँ। तो आपसे सवाल ये है कि जैसा कि आप डॉक्टरेट है स्ट्रक्चरल इंजीनियरिंग में, तो बैचलर के बाद किन बच्चों को स्ट्रक्चरल इंजीनियरिंग की तरफ जाना चाहिए या किसी और इंजीनियरिंग में ज़रा गाइड कर दें?
बड़ा अच्छा क्वेश्चन आपने किया। ये डिपेंड करता है आपके इंटरेस्ट पे, ठीक है? अगर आपका इंटरेस्ट स्ट्रक्चर्स में है, तो आप स्ट्रक्चर की तरफ चले जाएँ। अगर आपका इंटरेस्ट वाटर रिसोर्सेज में है, तो आप उस पे चले जाएँ, ठीक है? ये आपके इंटरेस्ट पे डिपेंड, जितना आपका इंटरेस्ट उस फील्ड में होगा, तो उतना ही अच्छा परफॉर्म करेंगे और आपका नेचुरल इंस्टिंक्ट उसमें होगा, ठीक है? तो ये आपकी उस इंटरेस्ट पे डिपेंड करता है। आप अपना जो आपका एरिया है जो आपको नजर आता है, मतलब बड़ा वो करते हैं। बाज लोग थ्योरेटिकली स्ट्रांग होते हैं, बाज लोग कॉन्सेप्चुअली स्ट्रांग होते हैं, बाज की मैथमेटिक्स अच्छी होती है, ठीक है। तो ये आपकी उस पर इंटरेस्ट पे डिपेंड करता है। आप अगर आपकी एस्टिमेशन स्किल्स अच्छी हैं तो आप उस में जा सकते हैं। उसके लिए सॉफ्टवेयर्स हैं, प्लान स्विफ्ट आजकल आपने नाम सुना होगा, बड़े अच्छे सॉफ्टवेयर्स हैं, यूज होते हैं फॉर एस्टिमेशन, और लोग अच्छा खासा उसमें से अर्न कर रहे हैं इंटरनेशनली, ठीक है, यूएस में, मिडिल ईस्ट में। तो ये आपके इंटरेस्ट पे डिपेंड करें। अगर आपका जियोटेक में इंटरेस्ट है तो आप जियोटेक साइड पे चले जाएं, ठीक है। इंजीनियरिंग में सारी चीजें आपको बेसिकली कराई जाती हैं। मास्टर लेवल पे फिर आप जो आपका सबसे अट्रैक्टिव एरिया है ना, फिर आप उस पर फोकस करते हैं, उससे फिर आप आगे ग्रो करते हैं।
ओके, थैंक यू।
जी, हमारे पास 2 मिनट है। अगर किसी का कोई क्वेश्चन है, कोई अगर चैट में सवाल पूछना चाहे आपसे पूछ सकते हैं। आफ्टर 2 मिनट्स हम फिर सेशन बंद करेंगे, तो काइंडली किसी का कोई क्वेश्चन आप पूछ सकते हैं।
अमाद, आप फिर वाइंड अप कर लो, और बाकी जो आपने बोलना है तो वो आप कंटिन्यू करो।
जी, एनी क्वेश्चन फ्रॉम एनीवन?
सर एक लास्ट क्वेश्चन कि ये जो आपने जो ट्रेनिंग के हवाले से डिस्कशन की, तो ये क्या कोई पर्टिकुलर टाइम पीरियड पे आती है या विद पैसेज ऑफ टाइम आती रहती है? कोई सेशन है आपका? ये बता दीजिए।
काइंडली जरा क्वेश्चन रिपीट करें, आपकी आवाज जरा क्लियर नहीं थी, मैं नहीं समझ पाया। किस टाइम पीरियड की बात कर रहे हैं?
सर ये जो आपने कुछ सॉफ्टवेयर पैकेजेस की ट्रेनिंग के हवाले से डिस्कशन की कि
जी जी
ये सॉफ्टवेयर की ट्रेनिंग जो है वो दी जाती है बिन पार्क के प्लेटफॉर्म से, तो
जी जी।
कोई पर्टिकुलर टाइम है जिस तक कि आती है या इंटरमिटेंटली आप लोग ऑफर करते रहते हैं एज पर रिक्वायरमेंट और एज पर डिमांड?
आप ऐसा करें, इसमें जो व्हाट्सएप का नंबर है ना, इस पे जाके आप ये क्वेरी पूछ लेना। ये डिफरेंट कोर्सेज या इनका जो फेसबुक पेज है या लिंक्डइन पेज है, उस पे ये ऑफर आते रहते हैं। और इनकी अपनी वेबसाइट भी है, शायद वो वेबसाइट यहाँ पे नहीं शो हुई, वो मैं कोशिश करूंगा कि आपको मिल जाए। तो उस पे ये सारे अनाउंस होते हैं, ठीक है। तो उधर से आप उसको देख सकते हैं, उसमें
राइट सर।
शेड्यूल अनाउंस होते हैं कि कौन सा इसमें डिफरेंट इंस्ट्रक्टर्स हैं। मोस्ट ऑफ देम आर पीएचडी लेवल इंस्ट्रक्टर्स और अपनी फील्ड में महारत रखते हैं। तो वो अपने अपने कोर्सेज पर डिफरेंट टाइमली ऑफर करते हैं, ठीक। आप किसी भी कोर्स में एनरोल होना चाहें,
राइट।
फिर आप उधर से इन्फॉर्मेशन ले सकते हैं।
ओके सर, ओके, थैंक यू।
वेलकम। सो एनी लास्ट क्वेश्चन इफ एनी, अदरवाइज विल
सर
जी
आप
जी।
अपनी पीएचडी में बिजी थे तो इस वजह से ये स्ट्रक्चर का कोई कोर्स नहीं हुआ, तो क्या आप बता सकते हैं व्हाट विल बी द राइट टाइम टू स्टार्ट द कोर्स, एनी
यस
स्ट्रक्चर
जी
रिलेटेड?
जी जी जी। मुझे इस पे बहुत ज़्यादा रिक्वेस्ट आई हैं, और आई एम वेरी अपोलोजेटिक टू एवरीवन। लोगों ने बड़ा इंतज़ार किया है। इंशाल्लाह विद इन 1 to 2 month आई विल बी एबल टू लॉन्च कोर्स ऑन स्ट्रक्चरल इंजीनियरिंग। तो इंशाल्लाह फिर आपको अपडेट कर देंगे उसमें।
थैंक यू सर, वी आर वेटिंग।
वेलकम वेलकम।
ओके सर, थैंक यू सर। मैं एएससी की पूरी टीम की तरफ से सर आपका शुक्रिया अदा करता हूँ। आपने इतना कीमती टाइम निकाला, और मैं अपने नॉलेज से, आपने अपना नॉलेज हमारे साथ शेयर किया। थैंक यू सो मच सर, ऑन द बिहाफ
Thank
ऑफ
you,
एएससी।
thank you for inviting and thank you for this opportunity. It was a very good session और बड़े अच्छे questions आए। Inshallah we will be again coming whenever required. Okay, thank you very much जी, और अपना ख्याल रखिएगा। इंशाल्लाह फिर कभी मुलाकात होगी। Thank you जी, अल्लाह हाफिज।
अल्लाह हाफिज।